Okay, this is a review of factoring. We're going to be looking at the rules of factoring and what type of polynomial you have and how that indicates which technique you should try. And what I mean by type of polynomial is the number of terms that you have. So let's just briefly review what does it mean to have something in factored form. So a polynomial is written in factored form when it represents two or more factors that when you multiply them out, they give us the original polynomial. To be completely factored, each factor can not break down any further and also cannot have any common factors within the parentheses. So we have to make sure that we're completely factoring and that we're factoring things so that if we multiplied them back out, they would go back to the original polynomial. So if you look at this first one right here, this is the original polynomial and this is its factored form. Now we're going to go over how did I know that this is how this factored in just a second. But if you notice, if you were to FOIL this back out, x times x is x squared, x times 3 is 3x, 2 times x is 2x, and 2 times 3 is 6. So let's write that out. So I'm just checking to make sure that this actually is the correct factorization. So this would be x squared plus 3x plus 2x plus 6. And notice that the middle terms are like, so it does add up to the 5. So some things to be concerned with is to make sure that when you FOIL it out or distribute it out, that it all comes back to the original polynomial that you started with. And that's going to depend on signs and factors and a lot of things that we're going to talk about in this video. So there are some methods to factoring. We're going to go through each one and then try some examples of each. You check to see, first of all, if you have a GCF. GCF stands for greatest common factor. You should always check for that first. That means you look at all of the terms in the polynomial and you say, is anything a common factor that can be pulled out? For example, if I have something like, so I'm going to go down to the rule for factoring out a GCF. We'll come back to the list in a minute. The first step to factoring any polynomial should always be to check to see if it has a GCF, and if you lead with a negative, you should also pull that out as part of the GCF. So just here's a couple of quick examples of this. So what if I had 2x to the third minus 4x squared plus 16? So notice that 2, 4, and 16 are all different terms, and let's put an x on this one as well, and they're all divisible by 2. So I can pull out a 2. Each of the terms also have at least one x, so I can pull out an x. That would make this x to the second, because 2 divided by 2 is 1. X cubed take away 1 would be x squared. Negative 4 divided by 2 would be negative 2. X squared take away 1x would just be x. And 16 divided by 2 would be positive 8. And then you take away the x. And then, of course, we would have to check to see if this factors further. I'm not worried about that right now, but this is just all you do to factor out the GCF. If you led with a negative, let's say negative 3x squared y plus 9x cubed y squared, let's say that was my binomial because this is two terms. My GCF here would be not just 3, but negative 3. If it's a leading with a negative, I pull it out. So this is negative 3, and then I have an x squared in common because they both have at least 2, and a y to the first in common. That would leave me with a 1 in the first spot because this is exactly the same thing as that first term. 9 divided by negative 3 would be negative 3. X take a third take away 2 would be just x, and y squared take away 1 would be y. So notice that that is now had the GCF factored out. The second thing you should always look for then after you've done the GCF is how many terms does your polynomial have? Is it a binomial, a trinomial, or does it have 4 terms? A binomial has 2 terms, a trinomial has 3, and 4 terms is just a polynomial. If you have 2 terms and you've already checked for the GCF, there's only 2 other possible ways that it could factor. A difference of 2 perfect squares or a sum or difference of 2 cubes. If you have 3 terms, it could possibly factor. Not everything factors, but if it does, you either have what we consider the easier trinomial factoring or the harder version. That depends on if there's a 1 in front of the x squared or not. So we will show you both of those methods in just a second. And if you have 4 terms, you want to try factor by grouping, which we will also show you in a minute. You want to make sure your resulting factored polynomial is completely factored. This means that there are no common factors inside any of the individual parentheses, and the parts in the parentheses don't factor any further using any of the methods from above. So what we're going to do in this next part is we're going to just show you a little easy example of each of the types, and then we're going to go do a bunch more examples just to get some variety. So factor by grouping, you use this method when you have 4 terms and you split them into pairs and you pull a GCF out of each of the pairs. This is not guaranteed to factor because no polynomial is guaranteed to factor. We're just checking to see if it does. So for example, what if I had 2x to the 4th minus 4x to the 3rd plus 3x to the 2nd minus 6x. Okay, so notice this is 4 terms. If I look at the first pair, I would see that, in fact, actually, let's stop before we go any further. We're always supposed to check, remember, for a GCF first. There is a GCF of x for all 4 terms. If you don't catch that now, I'll show you in a minute how it's going to show up again at the end. So if I pull that x out, that would be, let's pull it out in red. That would be x, and then I would have in the remaining part 2x to the 3rd minus 4x squared plus 3x minus 6. Okay, so this inside part is still 4 terms. So I'm going to try to factor by grouping. You pair them up, and you pull a GCF out of each pair. This x is going to come down as part of my final answer, so I can keep it in red. You don't want to lose that GCF you pulled out front. It is part of the final answer. So this would be 2x squared. We can pull out of the first pair, and that would leave me with an x and a minus 2. And then this would be a positive 3. I can pull out of the second pair. If this middle term here is negative, you will pull out a negative in your part. So whatever the sign of the second pair starts with, you pull that out. And then they both are divisible by 3, so that also leaves me with an x minus 2. The part that you have in each parentheses, if this is going to factor, it will match. So notice that's x minus 2 and x minus 2. We treat that as a GCF, so we pull it out to the front up here. So that's where that's going. The parts that are left over after you pull out the x minus 2 make the final binomial. So the answer is x times x minus 2 times 2x squared plus 3. If I had not pulled out the x at the beginning, I want to show you what would have happened there. We would have had 2x to the 4th minus 4x to the 3rd plus 3x squared minus 6x. We would have pulled a 2x cubed out of the first pair. That would have left us with x minus 2. We would have pulled a positive 3x out of the second pair. And notice that when you bring this together, you have a common factor inside this second binomial. We don't like that. That's not completely factored. So you would have had to catch it at the end and pulled that out to the front, that they both had an x in common. And then you would reduce it by an x in each of those. So you have to just be really careful. If you don't pull the GCF out at the beginning, it might mess up your answer at the end. So that is factor by grouping. Again, if you can't get the pairs to give you a matching parentheses, you can try to rearrange them and try it again. But if you've exhausted all ways of rearranging the 4 terms, then it's just not going to factor, and we consider something that doesn't factor to be prime. Now, I will point out that if you pull a GCF out, you can no longer tell me that something is prime. Pulling a GCF out is a factoring method. So the only way you can say something is prime is if nothing can be done. Okay, now we're going to look at the ones where you have 2 terms. So we did the 4 terms. Now we're going to look at what happens if you have 2 terms. You have a difference of 2 squares or a sum of, or difference of 2 perfect cubes. So remember, perfect squares are things like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and on and on and on. If you have two perfect squares with a minus sign in between them, that is a key thing. For something to factor using real numbers, to use integers specifically, we have to have a minus sign between the two perfect squares. If that happens, then it's the square root of each of these two terms one time you add them together and one time you subtract them. So for example, x squared minus 16. This is perfect square. 16 is also a perfect square. And there's a minus sign between. So since it fits the pattern a squared minus b squared, it factors into the square root of each of those numbers, once with a plus and once with a minus. Square root of x squared would just be x. Square root of 16 would be 4. So this is x plus 4 and x minus 4. You cannot factor a squared plus b squared, that's prime, unless you can pull a GCF out, but that is prime, because that factors using imaginary numbers, not the real numbers. So for us, we don't do anything with imaginary numbers yet, so it's prime. If you have perfect cubes, it's a little bit more complex. There's a formula to follow, but the factoring is a binomial times a trinomial. So you need to know your perfect cubes. So for perfect cubes, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Usually that's enough to get you through most of these. So let's say we wanted to factor x cubed plus 27. So we know that it's supposed to factor into a binomial and then a trinomial. And let me explain how this pattern works. These two guys are the cubed roots of whatever these pieces are. And then over here, you're doing pairings. You're doing the first one times itself, the first one times the second one, and the second one times itself. That's essentially what's happening. Each root is getting paired up. There's a way to remember your signs here, because if you notice, these are very similar formulas, just one of them has the negative in the trinomial, the other one has the negative in the binomial. The way you remember the signs is a nice little phrase called SOAP. SOAP stands for same as the original, opposite to the original, so whatever that is, and this one is always positive. So same sign as the original problem, opposite sign as the original problem, always positive. The reason this works is if you have those sign changes in the correct place, when you FOIL all this back out or distribute it, you'll get that a lot of your terms in the middle cancel out. So the cubed root of x cubed would just be x, so this will be an x. The cubed root of 27 is a 3, and then we keep the sign of the original problem, which in this case was a plus. For this part, you times x times itself for the first spot, and then x times 3 for the second spot, and then 3 times itself. So this is x squared, 3x, and 9. And then remember, using our sign rule, this is same as the original, opposite to the original, always positive. And we'll be doing more of these in just a second, but that is how you factor a sum or difference of two cubes. So the only difference between this having a plus or a minus is where the negative sign goes in the answer. So you could not factor perfect squares with a plus in between them, but you can with perfect cubes. All right, and that leads us to the last topic of what type of factoring can we do, because after this it's just going to be working through some examples. So if you have a trinomial, there's two general cases that you have to deal with. The first one is if you have a 1 in front, so something like x squared minus, let's say, 13x plus 30, okay? So 1x squared minus 13x plus 30. So we're going to try to factor this into two binomials where it splits x squared splits into x and x, because that's how it would split equally if you were multiplying it. And the reason we can do that is because it's a 1 in front. If there's something other than a 1 in front, you can't just throw in x and x. It's going to be a number and some x's. And then we list factors. We're looking for factors of this last number that will add up to the middle term. Now, it is very important that you look at the sign of this number right here. So the only way we can get factors of positive 30 is if they're both the same sign. Because something to multiply out and make positive, it has to be same sign. So this is just factors of 30. Start with 1, so 1 and 30, 2 and 15, 3 and 10, 5 and 6, because 4 does not go into 30 evenly. You know you have your complete list when your last pair is either back-to-back or any number between 5 and 6 does not divide evenly into 30. Now, this has to multiply to positive 30 but add to negative 13. So it looks like we need to use this pair, and they need to both be negative because negative times negative will make a positive 30, and they will both add together to make negative 13. Once you figure out the two numbers that work, you just place them into the two parentheses. So x minus 3, x minus 10. The reason I pointed out the signs is because I can do the same exact problem but change one thing and it completely changes how this factors. If you change this now to a negative 30 at the end, if you do your factors of negative 30, that's still 1 and 30, 2 and 15, 3 and 10, and 5 and 6. But 3 and 10 do not multiply to make negative 30 if they're both negative. So you can't make negative 13 with 3 and 10 here because they would both need to be negative to make that happen. So the way this one's going to happen is we're not going to add to 13, we're actually going to subtract to 13. So we're going to use 2 and 15. So if negative 15 and positive 2 were my two factors, let me go ahead and circle these because I didn't do that, then that would still add to negative 13, but it multiplies to negative 30. So the sign of that last number is very important. Now, to be able to use that sign as kind of a guide, you have to make sure that the leading coefficient is positive, otherwise the sign rules don't make sense. But in our case, it was a positive 1 out front for both of these. All right, let's talk about the other case, which is what if there's a number out front that is not a 1? And there's two ways you can factor those. You can do either factor by grouping, which is the way I actually teach it. That's sometimes called the AC method. It's another name for it. Or you can do trial and check or trial and error if you have seen that in a different book. I don't focus on trial and error because if you aren't what I would call someone who is very intuitive about factoring, then you don't need to be messing around with trial and check because it's really guess and check. And you have to foil a bunch of stuff to see if it works. So I think that most students would want a systematic approach to this. So we're going to look at the factor by grouping method. I have the notes on what trial and check is, but I wouldn't worry with it too much. So let's talk about how to do the AC or factor by grouping method. So let me see if I can make up a problem really quickly. Let's do 2x squared. I have to work this backwards in my head. This will be a minus 8 down at the end. I need a middle term. Let's see. How about 15? So plus 15x. Okay, so when we look at this, this has not got a 1 in front, so you can't really jump straight to x and x as your two parentheses. And when you do, so this is not a 1. That's the reason this one's going to be done a little bit differently. So if there's not a 1 in front, we do what's called the AC method. You multiply, this is called the A term, this is the B term, and this is the C term in a trinomial that is quadratic. So we multiply A times C together. So 2 times negative 8 is negative 16. You list factors of 16, which is 1 and 16, 2 and 8, and 4 and 4. Okay? We then think about our sign. To make a negative 16, we had to have different signs. So that means that to make it add up to positive 15 in the middle, we would need one of them to be negative and one of them to be positive so that this multiplies correctly and then adds correctly. So that would be a positive 16 and a negative 1. Now, you don't just put those into two parentheses. In factor by grouping, what we do is we create a fourth term. Because to do factor by grouping, you have to have 4 terms. So what happens is that this first term comes down, and then the middle term splits into the two factors that we just found. So a minus 1x and a plus 16x. It keeps this variable that's attached to that middle term. And then you bring down your last number, your minus 8. We factor by grouping. So we can pull an x out of that first pair. That would leave me with a 2x and a minus 1. The second pair starts with a positive, and they have an 8 in common. So that would also leave me with a 2x minus 1. Notice my 2x minus 1 is a match, so it is the first part of my answer, and it doesn't matter if you write it first or second, but I always write my matching part first. The parts in front of each of those make the second binomial. Now, if we're not sure, if you don't feel 100%, that is the answer when you're factoring. You leave it in the factored form. But you could FOIL this out. That would be 2x squared plus 16x minus 8, which does give me back the original polynomial. But the answer is this line right here. There is a special case. I would not worry about that so much. It's going to pop up when we do completing the square later on, so we'll talk about it then. You don't need to memorize too much all at the same time, and honestly, you don't really memorize this one. It's just a pattern. And anything that looks like these, you can do them using the factor by grouping or regular factoring trinomial method. So I try not to force you to memorize too many things. So for example 1, and this is the only example we have, I just did a lot of variations. We have a couple different problems we want to factor. So look at this first one. Always try GCF first. It looks like there's some things that could be pulled out. These numbers are all divisible by 11. We have at least 2 R's in every single term. And we have at least 3 S's in every single term. So if we divide that out, 121 divided by 11 is 11. R cubed take away 2 would leave me with 1R. S to the 4th take away 3 would leave me with 1S. 77 divided by 11 is positive 7. R squared comes out, and we would still have 1S. Negative 55 divided by 11 is negative 5. We would have 2 R's left over and no S's. So that is my factored form. Now normally you would check to see that the parentheses does not factor any further. This is a trinomial, but it doesn't fit the pattern for factoring. If there are 2 variables, then there needs to be a squared case of both of them, and we don't have a squared case there. So that one doesn't factor any further. Okay, so B, no GCF. You should always check that first. It's 3 terms, and it has a non-1 in front. So this is the factor by grouping method. So we do 12 times negative 6, which would be negative 72. Factors of 72. If you don't know them by heart, you get your calculator out. So 72 divided by 3 is 24. 72 divided by 4 is 18. 72 does not divide by 5. Divided by 6 would be 12 because it was 6 times 12 already. And 72 does not divide by 7, but it does divide by 8, 8 and 9. And notice 8 and 9 have nothing in between them, so that's the whole list. These need to be negative 72 and add to negative 1. So it has to be a positive 8 and a negative 9 because they have to multiply to a negative but add to a negative 1. Okay, so we're going to split this up. This would be 12x squared. It doesn't matter which one of these you write first, so I'm going to write positive 8x and negative 9x. That's this part right here, split into 2. And then minus 6 comes down. We factor by grouping. This would be, I can pull out a 4 and an x. That would leave me with 3x plus 2. This pair starts with a negative, so we are going to pull that out, and they're both divisible by 3. Negative 9 divided by negative 3 would be 3, and then I have my x. Negative 6 divided by negative 3 would be positive 2. So I do get a match of 3x plus 2, and then my leftovers are 4x minus 3. So there's how that factors. For C, it's a binomial. There's no GCF because 9 and 121 don't have anything in common, and the two variables are different. But this is a candidate for perfect squares because 9 is 3 squared. Y to the fourth would be y squared squared. 121 is 11 squared, and x squared would just be x inside. So it looks like this is the root and this is the root. So remember, when you have two perfect squares with a minus sign between them, you find the two roots and you write them once with a plus and once with a minus. And that is it. When you look at D, it looks like perfect squares, but there's a plus sign between the two things. So remember, we don't do that. This is considered to be prime as long as there's no GCF to pull out, which there is not. It looks like E is going to be perfect cubes because 8 and 125 are both perfect cubes. This would be 5x cubed and 2 cubed. So remember, if you have perfect cubes, you have a binomial and a trinomial. You write the 5x and the 2 roots in the first one. You keep your original sign between them, so 5x minus 2. For the trinomial, you times the first root times itself, the first root times the second root, and the second root times itself, so 2 times 2. That would be 25x squared, a 10x in the middle, and a 4 at the end. Remember, our rule is to do SOAP for the signs. Same as the original, opposite to the original, always positive. F is also perfect cubes. You have, looks like 27 is a perfect cube. Y cubed would be just Y. So that'd be 3 and Y cubed. Be careful with this one. Think about what would that be if it was cubed. Well, you would use the multiplication rule. 6 is 2 times 3. So x squared is the root of x to the 6 when you're doing cubes. So this would be, again, a binomial times a trinomial. You write the two roots with their sign of the original in between them. You times the first root times itself, the first root times the second root, and the second root times itself. X squared times x squared is x to the fourth. This would be 3x squared y, and then 9y squared. My signs are same as the original, opposite to the original, always positive. Okay, G and H look both, and I all look like they are 4 terms. We still have one more after that. So remember, when there's 4 terms, you try factor by grouping, but you also want to check, make sure there's no GCF at the beginning first. They don't all have an X. They don't all have a Y because this one's missing it, and they don't all divide by the same number because there's a 1 here. So we're ready to just go ahead and try to pair them up. I can pull an A and a Y out of the first pair. That would leave me with a 2Y minus an X. The second pair, I can pull out a positive 3 and an X. That would leave me with a 2Y and a minus X. So this one definitely factors into 2Y minus X and AY plus 3X. For H, notice that there is a perfect, or a GCF at the very beginning. You can pull a 5 out of all of these numbers. So I'm going to go ahead and do that right now. So that's a 5. That would leave me with x to the third plus 2x squared minus 4x minus 8. Notice I couldn't pull an x out because this last term did not have an x. We factor by grouping, and we don't forget to bring our 5 down each time. This would be x squared times x plus 2. I can pull a negative, since this leads with a negative, and a 4 out of this one, so that would be an x, and negative 8 divided by negative 4 is positive 2. This is, still got my 5 out front. My match is the x plus 2, and then I get the leftovers of x squared minus 4. This is why we wanted to point this out. That x squared minus 4 factors again. So I have my 5, I have my x plus 2, and then the x squared minus 4 is a perfect square, so it's x plus 2, x minus 2, because that's the square root of both of those. So you actually get another x plus 2 on top of the one you already had, and that's not because of these two right here, it's because this factors again. So these two right here came from the x squared minus 4. If you want to shorthand this, you can write that as x plus 2 squared. But you could also write it out as the separate x plus 2's. All right, let's look at I. So no GCF that we can pull out all the way across, but we can factor by grouping since there are 4 terms, or at least we can try. I can pull an x cubed out of the first pair. That would leave me with x minus 3. I can pull an 8, a positive 8, out of the second pair. That would also leave me with x minus 3. So I have an x minus 3 and an x cubed plus 8. Again, this factors because it's 2 perfect cubes. So I have my x minus 3 from here. And let's go over here and work on x cubed plus 8. Cubed root of that is just x. Cubed root of 8 is 2. So this would be x plus 2, because we keep our roots and our sign. X times x is x squared. X times 2 is 2x. 2 times 2 is 4. And then remember SOAP. Same as the original, opposite of the original, always positive. So I get an x plus 2 and an x squared minus 2x plus 4. Now the nice thing about perfect cubed formula is that as long as you've taken care of any weird GCF stuff, which we didn't have any with x cubed plus 8, that trinomial will be non-factorable, so you know that it is completed. And our final example is this one right here, which looks like it starts off with an x that can come out because it has a GCF, so that would be 4x squared plus 4x plus 1, because x divided by itself is a 1. And this is a trinomial, and we're going to have to do factor by grouping, so 4 times 1. And this would be 1 times 4 and 2 times 2. To add to 4, since this is a positive 4, you would need the 2 and 2. So this would be, I'm going to bring my x down. This would be 4x squared plus 2x plus 2x plus 1. Pull a 2x out of the first pair. And the second pair have nothing in common, but you have to pull out something. So we pull out a positive 1 since this leads with a positive. So notice this has a 2x plus 1 that matches. That's this guy. So this right here, this x came from up above. These matching turned into this one, and the leftovers turn into another 2x plus 1. So that's where that guy is. So this is x times 2x plus 1 to the second. And that is the end of this video.